Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0117 indicates a problem with the Engine Coolant Temperature ECT Sensor 1 circuit, signaling a low voltage condition. The ECT sensor is critical as it monitors the temperature of the engine coolant, providing data to the Engine Control Module ECM for optimal engine performance and emissions control. Located near the thermostat housing, this sensor features a two-wire connector that communicates vital temperature readings, affecting various engine functions, including fuel injection and ignition timing. This code may trigger when detected temperatures exceed 356 degrees Fahrenheit, 180 degrees Celsius, or drop below 0.08 volts. Therefore, it is essential to record freeze and snapshot data prior to troubleshooting to understand the vehicle's recent conditions before the error was logged, ensuring a systematic and accurate diagnostic process. The ECT sensor plays a pivotal role in monitoring the engine's coolant temperature. Positioned near the thermostat housing, it provides data that helps the Engine Control Module ECM maintain the engine's optimal operating temperature. This sensor is crucial for managing fuel injection timing, ensuring efficient combustion, and reducing harmful emissions. When the ECT sensor registers a voltage drop below 0.08 volts or reaches excessively high temperatures of 356 degrees Fahrenheit or more, the DTC P0117 code is generated. Thus, understanding the precise location of the sensor and its function is vital for effective troubleshooting. Problems in this circuit can lead to poor engine performance and increased emissions, making timely repair critical. When encountering the DTC P0117, several underlying causes must be investigated. A faulty ECT sensor is the primary suspect and can lead to erroneous readings and signal communication failures with the ECM. Additionally, wiring issues, such as frayed or damaged wires, can disrupt electric signals, producing low voltage readings. Poor connections or loose terminals at the ECT sensor or within the electronic control module, ECM, can also contribute to this code appearing, showing the importance of securing proper electrical connections. Each of these possible causes must be considered during the troubleshooting process to accurately pinpoint the failure point and ensure the correct parts are addressed. Drivers encountering the P0117 code may notice several symptoms indicating underlying engine issues. The most immediate indicator is the illumination of the malfunction indicator light, MIL, on the dashboard, which serves to alert the driver to a fault. Additionally, poor engine performance can manifest through rough idling, acceleratory lag, and decreased fuel efficiency. Increased emissions can become apparent as problems with exhaust output may emerge. If left unresolved, these issues can lead to more severe engine complications, affecting long-term vehicle reliability. Recognizing these symptoms early on is essential for timely diagnosis and repair, preventing further damage. Beginning the troubleshooting for DTC P0117 necessitates turning the ignition switch to the on position, activating the vehicle's electrical systems without starting the engine. Using the Honda Diagnostic System, HDS, assess the ECT Sensor 1 data. If the reading indicates a temperature of more than 356 degrees Fahrenheit or 180 degrees Celsius or a voltage of less than 0.08 volts, proceed to the next troubleshooting step. This initial test helps establish if the problem lies within the sensor readings or if the system is presently functioning correctly. It's essential to verify these values accurately as they guide the subsequent steps, revealing whether the issue is transient or persistent. After recording data, switch the ignition to the lock position and disconnect the ECT sensor 1, which has a 2-pin connector responsible for measuring coolant temperature. This step allows for a more thorough investigation of the sensor functionality. Next, turn the ignition back to on 2 to enable data monitoring. Again, using the HDS, check the ECT sensor 1's data. A reading of greater than 356 degrees Fahrenheit or 180 degrees Celsius, or less than 0.08 volts, indicates ongoing issues with the sensor or wiring. If readings are as expected and show normal values, it suggests that an intermittent failure has occurred. Diagnosing these particulars brings vital clarity to the troubleshooting efforts. Once the ECT sensor 1 has been checked, turn the ignition back to lock 0 to ensure safety before performing any electrical disconnection. The next step involves jumping the SCS line or the Security Communication System line with the Honda Diagnostic System, HDS, to access further diagnostic functions. Disconnect the ECM-PCM connector B, which comprises 49 terminals. This step allows for testing the continuity and integrity of the wiring. By isolating the ECM from the ECT sensor circuit, it becomes possible to identify whether the fault lies within the ECM, PCM, or elsewhere in the wiring implementing this circuit. Having disconnected the ECM, PCM, the next step is to check for continuity between the ECT sensor 1's 2-pin connector terminal and the vehicle's body ground. This process ensures that the sensor's wiring is intact and capable of transmitting signals to the ECM. With a multimeter, test if there's continuity from terminal number 1 at the ECT sensor to the body ground. If continuity exists, this confirms that wiring is functioning correctly, suggesting the root of the issue is likely within the wiring loom or the ECM-PCM itself. If there is no continuity, this necessitates further investigation of potential wire shorts or breaks within the circuit. If continuity tests reveal a break or lack of signal in the ECT sensor circuit, the next step is to replace ECT sensor 1. Following this, reconnect all related connectors securely to ensure robust electrical connectivity. Ensuring all connections are clean and free from corrosion will help restore the circuit's normal function and prevent future DTC occurrences. After replacing the sensor, turn the ignition back to on, second set. To perform further tests on the newly installed part, this stage emphasizes the importance of proper installation and securing connections to avoid future errors, making attention to detail vital during assembly. After all repairs and replacements, it is crucial to verify the effectiveness of the fix. Start by turning the ignition to the on position. Using the HDS, reset the ECM-PCM, which restores original factory settings and clears any trouble codes stored in the module. Following the reset, perform the ECM-PCM idle learn procedure, essential for optimal engine running conditions. This process recalibrates the engine settings for improved idle control and responsiveness, confirming both the sensor and the circuit are functioning correctly. Ensuring that these last steps are meticulously executed solidifies the repair and helps prevent DTC P0117 from reappearing in the future. To prevent future occurrences of DTC P0117, implementing a structured preventive maintenance routine is beneficial. Regularly check the connections at the ECT sensor and the ECM/PCM for any signs of corrosion or looseness, which could lead to intermittent failures. By inspecting the wiring for any damage, wear, or fraying, potential issues can be addressed before they result in circuit problems. Additionally, ensuring that the ECT sensor remains clean can promote accurate readings and effective operation. Maintaining these components will extend their lifespan and reliability, resulting in consistent engine performance and lowered chances of encountering DTCs. In summary, DTC P0117 highlights a critical issue within the ECT sensor circuit, which directly affects engine operation and performance. By following a systematic troubleshooting guide, including initial data checks, physical inspections, and component replacements, accurate identification and repair of the issue can be achieved. Each step in the troubleshooting process serves as a foundational building block in narrowing down and resolving complex electrical issues. Furthermore, establishing a routine preventive maintenance plan will mitigate the chances of similar codes arising in the future and maintain optimum engine functionality. Awareness of the symptoms and consistent monitoring can enhance the longevity of the vehicle's engine management system, leading to more reliable performance. Please like and subscribe to the channel. See you next time!